Alright, now we're going to talk about the process of setting up host-based authentication. So I did kind of show this in a past casual video, but I ran into a lot of technical difficulties, and I feel like you're better off not watching that tutorial at that point. So I'm probably going to make a very concise tutorial of it in the future, but I decided for now, since I actually have some SSH devices to set up for host-based authentication, I may as well show it again since I have to set this up anyway. I have a bit more preparation and less things should go wrong now. So there's basically two different ways to do it, and it is actually quite simple. One of the reasons I want to show this is because it's kind of hard to figure out the steps for setting it up. As you're doing it mainly because you don't want to have to enter a password when using SSH. Like if you're automating something, obviously you might want to bypass a password. If you're automating something that makes an SSH connection, you have a few options. You can either do host-based authentication, so you don't have to enter a password, but it's still secure because of the host keys. So that would allow you to not require a password. But because it's so complicated to figure out, you may end up looking at alternatives, such as using SSH pass, so you can just kind of pass through the password in the command itself. Or you may end up creating an expect script or something that automatically puts in the password for you. Those are not very good solutions ultimately. Host-based authentication, in my opinion, is really the only way to go. The problem with that is it's kind of hard to figure out how to do it, which is what I'm going to show right here and now. I apologize about this ramble. We're getting into it now. So there's two different methods, and usually it's all based on whether or not you have password-based authentication enabled or not. So there's kind of an automatic way. If you're able to get in with a password, it saves a lot of steps. As you can't get in with a password, that's what the other technique is for. I'm going to show them both here because on one of my devices, I have a password, so that'll be easier. On the other device, I don't. So I'll be showing both methods in this demonstration. Without further ado, let's start. So I basically want to authenticate my Raspberry Pi with my Linux machine right here. Currently, they're not set up for host-based authentication, so that's what I'm going to do here now. So the Raspberry Pi does not have password-based authentication, so I'm going to have to do the manual method for that. I could do the automatic method connecting the Pi to this machine though. I apologize, like if it's confusing what's what, you'll see how it works later. So this is, in this case, this is going to be the client that I'm using to connect to this device. That's how this first step is going to go. So I want to connect this to this. So we can use that first method with the password-based authentication. So I'm going to open up a terminal, make it a bit bigger, and then I'll show the steps. It's kind of hard to figure out the steps, but I can assure you, when you do figure it out, it is the way to go when it comes to like automation and security. So let's connect to this machine first of all. So I'm gonna normally connect to it because I think I have to establish permissions. Yeah, so I haven't done that yet, so I can just say yes. Then I have to enter a password. And then it connects as you would expect. So now I'm connected via SSH, but you saw that I had to punch in a password there. So let's set up host-based authentication instead. So I'm going to exit to close out of the connection. So how do we do that? Well, since this is the client, I believe I want to go onto this machine. And in the terminal, I want to run SSH keygen -t RSA. And then we can set it as a default, but you can do this however you want. I'm not going to enter a passphrase because I can use the key-based authentication. There are other encryption options available for SSH besides RSA, There's also like ED25519, which is supposed to be much more secure, and many other options are available too. I typically use RSA. So now we've generated some files. So if we go into .ssh, we now have two files, an ID RSA and then a .pub. So this is a private key and this is a public key. Later in this video, I'll explain about that because the next part of the video will also show how to do this with PuTTY and WinSCP. And I explain the whole private public key concept there, so I'll let my past self talk about it when we get to that point in the video. Otherwise, this stays on the system and the contents of this needs to get added to the Raspberry Pi. So actually, I'm now realizing I'm going to actually start with the harder method first, and then I'll do the easier method next. So if I try to connect to the Pi, you'll see that I can't because I have host-based authentication on there. So I can't connect to the Raspberry Pi right now, but the step I'm about to do will allow that to happen. Because I don't have password-based authentication, I have to do method 2, which apparently I'm going to be showing first. So if you don't have password-based authentication, you need a flash drive or some other method to transfer a file essentially. If you have access to the other machine, I recommend temporarily enabling password-based authentication on there for convenience instead of using a flash drive. That way you could use SSH copy ID method instead and disable the password afterward. That could help avoid the manual key transfer. So what we're trying to do now is this ID RSA.pub. We need to add this to the Raspberry Pi. So we're going to put that file on a flash drive and we'll be able to do that. That's the easiest method for me right now. So I'm going to plug that into this computer. And then I'll go to lsblk to find the device because this is how you would do it in Linux. Again, I will show PuTTY and WinSCP in a bit. So the device I want is this one. This is probably where I'm going to put the file. So I'm going to temporarily mount that dev std3 to mnt. And then I'm going to copy the ID rsa.pub to MNT, I believe. Yeah, that's fine. There's a file already in there, but I think I just overwrote it. Okay, so now that I have that, I'm gonna safely eject the drive. I think this is how I would do it, I'm not entirely sure. Now that file's on the flash drive. So now I can put this in my client machine. Basically the other machine for now. We're gonna set it up both ways. So now I'm at machine, the drives are there. So I want to come to here. This is that file that I just added. Come on, mouse. My mouse glitches out sometimes, so I'm gonna copy that and we're gonna go into that directory. I want to just go to where it is, and there's a space in there, so that's why that didn't work. Actually, I'm gonna go into the .ssh folder, and then what I'm going to do is cat the file that I just copied to it, the ID rsa.pub, and I'm going to append that to authorized keys, and then that adds a host key. In case you didn't know, I'm using tab to autofill when you see a bunch of text auto-completing at one time. So something to keep in mind is you have multiple devices with the same user at the host name. You're going to want to make sure that whatever you're doing, you should really only have one. If you have any duplicates, you may have to either get rid of them or identify the same host name by IP address, which shouldn't be duplicate. Because what's going to happen is it'll look for the first one, and then that counts as that device's host key. If there's a later one, it's not going to take effect at all because it took the first occurrence of a given name. So like I have this one and this one. So therefore, this is the one that's going to apply, not this one. So if a host key isn't working, that's probably why. you want to make sure that there aren't any duplicates. And if there are, then make it so that whatever you want to actually do is the first occurrence of that thing. So that could be a problem that you can run into. I obfuscated some of the key, by the way, even though that may not have been necessary. But yeah, now that I've added the key to the authorized keys file like that, I should now be able to run that SSH command again. And now it works because I set up host-based authentication. So actually there is one other thing that we do technically need to do to make it work the way this currently is. So we want to go to the etc sshd config. You can use nano if you're not familiar with Vim for the text editor, but I am familiar with Vim, so of course I'm going to use that. The first thing you need to change in this file is challenge response authentication. So this line right here, the challenge response authentication, this should be set as no. If it's set to yes or anything else, set it to no. So we're not only setting up like key-based authentication, but we're disabling password-based authentication and doing good security practices. So then we go to the password authentication, which is right here, set that to no as well. Then set use PAM to no, like that. And then permit root login. That should also be set as no. And make sure that they're all uncommented, that there's no like pound symbol right here. They should all be uncommented. And then once you do that, save it out, and then restart the SSH service by doing that. Or if you're using a different init system besides systemctl, basically restart the SSH service however you would do that. And then it should be ready to go. So I've set it up one way. So now this device can connect to the Raspberry Pi, as you can see. So I would exit. So it can connect that way. But if I try to connect the other way, then I still have the password-based authentication. So now I'm going to show the other method, which is easier. I showed the other one first because I had them mixed up. But regardless, both methods are in this video. And it all depends on whether or not password-based authentication is still enabled or not. It's technically the same process for both methods. It's just how do you get the SSH key onto the other device? In this case, I did not have password-based authentication, so I had no way to get in. Therefore, I needed a USB flash drive to get it on the other device. But in this case, since I have password-based authentication, I can use that method to get it on the device over the network. A network share obviously would have worked too. I just use a flash drive because given my setup, it's the easiest way to deal with it. So now we need to fix this. How do we get that to no longer be password-based? I want to just have it go right in with host-based authentication. Well, let's do that now. So now, as you can imagine, I run that SSH keygen -t RSA just like the first time. That's the step one. It already exists. Overwrite. I'm not going to do it. I kind of showed how it is the first time. Then you can hit enter on the enter passphrases and stuff. And yeah, you get how to do that. It already exists for me, so I'm going to use what I already have. I already showed that first step elsewhere. So, okay, we got through this. What's the other method to getting it on the device? So basically you could use SSH copy ID -I and then reference that ID RSA.pub and then where are you sending it to. In my case, I'm doing for the server that because I'm trying to get connected to this device without password-based authentication. So this is where I do that. I do it on this device. And then I have to enter the password to get it transferred. So now I got the key installed. what I did with the flash drive before automatically got done with that command. So now it's time to configure this to not do password-based authentication anymore. So once again, I do sudo vim etc sshd config challenge response authentication. For some reason, I don't have a challenge response authentication, so I might want to consider adding that myself. Challenge response authentication. No. Not sure why it wasn't in this file. Usually it is. And then find password authentication, uncomment that, change that to no. It just said yes before, but now it says no. Then I find the use PAM, change that to no, and then permit roots login, no. So I just change that to no as well. Those are the changes you want to make. Save that out, and then restart SSH. And then it should have taken effect. So now if I come back to this device, I should be able to connect without it asking for a password. There we go. Now it no longer uses password-based authentication. So obviously, if I got rid of my public or private key, this would stop working. This may look like it's less secure, but you'd have to get the public and private key. Whereas with the password-based authentication, all you need is a password. The past me is going to end up explaining that in a bit when I talk about PuTTY and WinSCP. But for now, that's how you set up host-based authentication. And I kind of didn't do the best job explaining which was a client, which was a server. But hopefully you can see how I did that and then how things applied based on what literally happened just now. So now, past me from a previous video, we'll talk about how to set this up with PuTTY and WinSCP. So I want to try to get host-based authentication in PuTTY first. So let's say I want to connect to my Raspberry Pi real quick. I try to do my normal Pi. It literally says no supported authentication methods available because it's using host-based authentication. So now what? Well, with PuTTY, you can generate a public and private key that'll work with that. So if you need a little reminder kind of how that works, there's a key that's public and a key that's private, which is quite a bit different from a typical password. So one way you can think of it is, let's say that your password is the color green. Well, if you use a host-based authentication instead, metaphorically speaking, let's say that your public key is yellow and your private key is blue. And one of them won't work without the other, but when you combine them together, that makes green, which is basically the password, if you will. And all of a sudden it works because you have green. It's just you have a public and private key. When they come together, then the authentication can happen, because it's ultimately what your password is when you use them together. So of course your private key is stored on the device that you're using to connect to whatever. The thing you're connecting to will store the public key. They'll come together and that'll work if there's a match. So the public key has some information, the private key's got some information. When you combine them together, you can have proper authentication. That's why it's a little more secure than using passwords. Because a password, if somebody gets green, well then they can hack in. Whereas if they have either yellow or blue, they're usually not going to have both. And in order to get one set up, you have to actually get into the machine to install one of these keys in the first place. And if you can't get in, then that's not likely to happen in the first place. So yeah, that's just less likely to happen than a password getting stolen and used. So that's kind of, I guess, a way to describe how public and private host keys work. So if you want to set up PuTTY for SSH authentication, then you want to use what's called PuTTY gen, which is kind of like SSH keygen on the terminal. So essentially what you want to do is generate probably an RSA. You can do whatever you want there. Click generate. Then since you can't generate true randomness, it'll just take random mouse movements, and that's where the randomness essentially comes from. So this is a public key right here, so you might want to store it for later reference. I'll copy it to the clipboard for now. I can save it as a file, or I can just copy it here to paste later. And of course I could put a passphrase here if I want to, but I don't usually do that, as you know. So then you save the private key, and I'll probably just save it to the desktop for now. So I'll call it private or something like that. I don't care. So that's where the private key is stored. So I have the public key now. So the public key should go onto the device that I'm connecting to, which is a Raspberry Pi. So as you know, I have the Raspberry Pi right here. So this is where I need the public key. So to add that, I'm going to go into my SSH folder. So all the public keys are typically stored in the authorized keys file. So to add that, I'm just going to do echo that key, pipe it to T-A. Probably not the best way to do what I'm doing, but it'll work, I'm sure. Authorized keys. And then now that key should be added to the file. Authorized key, this should be in there now. So now I have the public key on the device I'm connecting to. Now I need to use a private key. So back on the Windows system, I want to go to SSH, click this auth right here, and then I can browse for my private key, which is right here. So now that I have the private key, I should now be able to go to here and try it again. If I type in the user, now I'm in. So that's how you do it. So a couple other things to keep in mind is you normally have to load that private key every time you want to connect, which can be kind of a pain. So you can save a session. I'm actually going to do that in a little bit, because another thing you can do is to specify the username somewhere. Right here under our login, you can specify the username like Pi. Then I can browse for my private key, which is here. And then what I can also do is save my session called, let's just say, Raspberry Pi. So to make sure I'm on that session, now I can punch in the IP address, hit open. I thought that was gonna auto log in since I specified the username. Oh well, it had the private key at least. That's the main thing. So that's how you use PuTTY with host-based authentication. WinSCP has a very similar process. You use PuTTY gen for WinSCP as well. So let's open that up now. It's practically the same if we're being perfectly honest. So you just do a new session like this. Then you want to go to advanced, I think. Under authentication, right there. Then you want to select your private key file once again. You might be able to do a similar username thing that I just did before. If not, then well, you can just fill in this information. I'm not going to put in a password though. So you can save the information. And it should have the private key on record. Then I can just log in. And I'm in. So that's how you use WinSCP with host-based authentication. Not that bad at all, as you can see. So since I showed how to do host-based authentication with SSH, how do you do it with Ansible? So if you remember, Ansible was how I was dealing with the password-based authentication. And also I forgot to mention, I no longer use that password stuff because of host-based authentication. I assume you probably would have been able to infer that. But yeah, I no longer retrieve a password from a file. It's all host-based authentication now, so it's completely unnecessary. So of course, with those steps that I previously showed you, where it failed, I'll prove to you that it works on a different system. So the one that I normally connect to, that refused because I just had the IP address wrong. See? That's with host-based authentication. No password required. And Ansible actually slows things down significantly, which is another reason I don't use that. So I want to show how I use host-based authentication with Ansible now. So it's actually pretty straightforward once you have normal SSH set up. So rather than configuring SSH completely with Ansible, you could use the normal SSH protocol to basically set up host-based authentication. You still have to make some changes to the settings. So the first thing is in the Ansible.cfg. I won't run it as sudo because I already did this. So in etc Ansible.cfg, which I talked about in the previous video, what you want to do is, at least what I'm doing, is adding these variables here. So strict host key check equals no, host user known host file equals dev null, and forward agent equals yes. That's what I have configured in the Ansible.cfg file. And then in the normal Ansible file, in the hosts file, this is what I have. So I specify the IP address of a group like I normally do, or multiple IP addresses. Then I specify the port and user, but I don't need to specify a password because of the key host-based authentication. So this is all you have to do. And yes, it does work. So I could do Ansible Nookie, which is a group -a. Then I could do like echo hi there or something. And assuming that it came back just fine using the host-based authentication. So the reason I don't use Ansible for this is for Minecraft is because it just slows things down. It's a lot slower than using SSH directly. So unless I'm doing multiple computers together, I'm going to do it regularly and not with Ansible. With Ansible, if I'm doing 2 or more systems, then I'll use Ansible for that. Or else I'll just use multiple commands for each system. But Ansible is quite useful for this. One of the technologies I'm going to try learning this year is Ansible Playbook, so I might be able to utilize it even further in the future. So yeah, that's how you do host-based authentication with Ansible. It's quite simple, isn't it? Once you get the normal host-based authentication set up. Now, if the IP address changes, you will probably have to change something. I can't remember. There's some stuff you might have to change with the host-based authentication if the IP address changes. It depends on whether the authorized keys file has an IP address or host name. If it has an IP address, you just need to change the IP address to reflect the new IP address in the authorized hosts file or authorized keys. This is not facing the internet, so it honestly doesn't matter that you're seeing this right now. But because I could change this at any time, and that's what I'm probably gonna do. So don't think I'm keeping this forever either, even though it doesn't matter. So like how I have a Zinzi23 at the host name. If this was at an IP address rather than a host name, I would need to change it to reflect the new IP address if it changes. That's where the host name is actually quite useful. You don't have to change that. So this is for devices connected to the Raspberry Pi, just so you know. But yeah. So that's what has to change if the IP address changes. And this is how I do host-based authentication on Ansible, and why I hardly even use Ansible at this point. So there you go. So I still have to specify a port in the username for a given group.